Okay, let's take a look at the homework questions on number 17. So the first one asks you to determine if a relation is a function. And in this case, we're looking at ordered pairs. And when you're looking to determine if ordered pairs represent a function, you're looking at the x values here. If any of these x values repeat with a different y value, like this one here, it repeats a -3, and it has different y values, so that one is not a function. But this one here has no repeating x values, so that one is a function. Again, no repeating x values with different y values. Let's try that one more time. This time, they want to know which one is not a function. So look at your x values. This has no repeats, so this is a function. The first one is a function. Let's take a look at the second one. No repeats, so that one is a function. Let's take a look at the third one. It does have a repeat. It repeats with different values. So the third one breaks the rule, right? You can't have any repeating x values with different y values. So that one is not a function, which is what it asked for. Which relation is not a function? That's what this question is asking as well. Which ordered pairs are not a function? So I'm looking for repeating x values with different y values. So that first one, not a function. Every other option here has all unique y's, right? None of these y's have any repeats. They're all unique. So let's take a look at the next task. Determine if a graph is a function. So for this one, you only have two choices, function or not a function. So all you need to do is take that vertical line or your pencil, scan it across your graph, right? Drawing that vertical line as you go down, checking to see if you ever touch the graph in more than one location. This one passes. I can never use, my vertical line is never going to touch that black squiggle more than once. So that passes, it is a function. Now let's take a look here. If I scan my vertical line, you notice how I touch the function in two separate places? So that is not a function. Alright, let's use our vertical line test one last time. When I draw my vertical line, I touch in two different locations, so that is not a function. Alright, let's take a look at the third one. Graphing lines given an equation. You start here at the y-intercept. So we're going to plot a point at -1. Now from here, we are going to use our slope fraction. 5 is the rise, 3 is the run. 5 is the rise, 1, 2, 3, 4. 5 is the rise, 1, 2, 3 is the run. So I take my cursor, my mouse, 1, 2, 3, 4, 5, 1, 2, 3, click. Let's do that one more time. Start at the y-intercept, -4, and follow the rise and run. 1, 2, 3, then the denominator is 5. Positive 5 is to the right. 1, 2, 3, 4, 5. Click again. Let's try another one. Alright, y-intercept is 2. Now this time, my slope is not a fraction. If it's not a fraction, you put a 1 underneath. Now be careful here. You're going to go down 2, but you're going to go positive 1 in the denominator. -2 in the numerator, but a positive 1 in the denominator. If ever you have a negative on the side, I just want you to give it to one number. Usually giving it to the numerator is easy, but you cannot give it to both. So we're going to start graphing at -2, and then we're going to go -1, that means down, and positive 3, that means right. Down 1 over 3, down 1 over 3, down 1 over 3. It works every time. Next lesson, finding the slope from points. So So you're going to need to get your calculator out. You're going to set up your giant subtraction fraction. You're going to look at your two values. I'm going to write these points right up here. And you're going to put these in your subtraction fraction. Y minus y over x minus x. And then you're going to pick up your calculator. You're going to type that whole thing in. And if you don't have a calculator with a big fancy fraction button, then you do one thing at a time. This is what I mean. Let me take a screenshot of this real quick. So if I have my calculator, where is it? So if you have a calculator, oops, sorry, but it doesn't have a fraction button, then you can do each of these pieces one at a time. Negative 19 minus negative 7. So you can type negative 19 minus negative 7. And we're going to get negative 12. And then we'll do negative 2 minus negative 4. So negative 2 minus negative 4. And now we know that our fraction is going to have the values of negative 12 over 2. And if you don't know what that is, you can use your calculator to divide. Negative 12 divided by 2 is what you would type in your calculator. You can press your ABC button, or you can press the division button. There it is, negative 6. So I'm going to type that in here. And the next one, you're going to do the same thing. Now you could use your giant fraction button, right? If you have one of those calculators that has this button, you could type the whole thing in. So negative 8 minus negative 8. Negative 8 subtract negative 8 is my numerator, y minus y. And in the denominator, I have negative 9 minus negative 10. I have negative 9 minus negative 10. And you can put that whole thing in. And we got a value of 0 because negative 8 minus negative 8 is 0. And that can totally happen. Okay. So again, set up your giant subtraction fraction. In this case, we're going to do y minus y over x minus x. And if you don't know how to do that and you're using a calculator, which for us would look like this, 5 minus 0, whoops, I forgot to type the whole thing, over 0 minus 0, and you'll see we get an error. Right? You can't divide by 0. Anytime you get an error, you know you're going to click this word, undefined. Okay, let's take a look at find rates from a linear function. So your rate of change has to be the rise and the run between two perfect corner points. Rise and the run. Here's one perfect corner point. Here's another, here's another, here's another. Looks like up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So that has a rate of change of 1. Let's do that again. Find some perfect corner points if you're looking at a graph. And over here, you just need to pick any 2 points you want. Y minus y over x minus x, 5 over 4. That's it. Pick any 2 points that you want. Y minus y over x minus x. Again, any 2 points you want. I'm going to pick these two. Y minus y is a 12 over x minus x. It's a 3. 12 over 3, 12 divided by 3 is 4. So from a table, you pick any 2 points you like. For a graph, you count the rise and run. And now we're getting into the actual standard question, what an 8th grader is expected to do. You're expected to be able to compare rates of change between different styles or formats. So when I look at this equation right here, the rate of change is -4. The rate of change is this number here, which is -4. We want to pick a function that has a lesser rate of change than -4. So when I look here, I can find the rate of change. When I look here, I can find the rate of change. When I look here, I can find or calculate the rate of change. When I look here, I can calculate the rate of change. So in the tables, I am using that y2 minus y1 formula, but for the graphs, I'm counting the rise and the run. My marker, what is wrong with it? Anyways, so 30 minus 15 and 2 minus 5, right? 11 minus 9 and 6 minus 4. So I have a difference here of 2, and I have a difference here of 2, so that's 1. That is not less than -4. I have a difference here of 15. Over here, this is a difference of 15. This is a difference of 3, and 15 over 3 is 5, and that is not less than -4. So over here, when I count, down 1, down 2, down 3, down 4 over 1, that has a rate of change exactly the same as the equation, so that must mean this is the winner. Down 1, 2, 3, 4, 5, 6, down 6 over 1, so that's the winner, letter D. So you've got to use all of your techniques, right? You've got to be able to see it from an equation, you've got to be able to count it from a graph, and you've got to be able to compute it from a table. So let's see. The table below represents a linear function. Which relationship has a function with a lesser rate? Well, first you got to find this rate. Y minus y over x minus x, -8 over 4 is -2. So we're looking for something that is less than -2. All right, well this one right here is -2, so that's not lesser. This one is 1, 2, 3, 4, 5, 5, 2, that's higher. This one is 1, 2, 3, 4, 5, 6, down 6 over 1. Okay, and this is 3/4, that's positive. It's definitely not less than -2, so that makes D the winner. -6 is definitely less than -2. Try this one last time. Can you calculate the rate of change here from 2 perfect corner points? This is one of them. This looks like another, this looks like another, this looks like another, so I know I'm doing it right. So here and here. Up 2, left 1, or down 2 over 1. So -2 is the slope. Which function has a lesser slope? Well, this is not less than -2. Positive 5 is not less than -2. So now I've got to calculate these tables. It looks like this one is going down 16. So -1 minus 15, that's -16. 0 minus -4. -16 over 4 is -4. That is definitely less than -2, so I found my winner. Let's see, I don't even have to do the last one. Woohoo! Alright, this last unit, find rates in context. The table below represents the number of miles, y, that the satellite Space Explorer flies in X hours, so we want to find the miles per hour. We can choose any value here. That would give us the rate of change, but just dividing y by x would give us the unit rate. So we're going to do 41,400 divided by 9. 41,400 divided by 9. It's 4,600. And if we chose this other one, we'd get the same thing. 59,800 divided by 13. See, we get the same answer. So it doesn't matter which one you choose to get your unit rate. Okay, for this one, we'd want to know how much it is for 1 hour, but that would be right here. We'd have to estimate that. So here's what we're going to do. We're going to find the average rate of change between these 2 points. So all I need to know in order to do that is the rise and the run, but I'm just going to use these numbers. 452 minus 226 and 20 minus 10. 452 minus 226. 452 minus 226. That's 226 over 10, because 20 minus 10 is 10. And I get 22.6. 22.6 miles per gallon. Again, they gave us 2 points, and all we have to do is calculate the rate of change between those 2 points. Okay. So we'll model it here on the side. Even if you just had that fraction button and you were using 131 minus 6 and then 10 minus 0, even if you put the whole thing in a fraction, 25 divided by 2, you actually have to do that. 12.50 per week. Gotta add that 0 in. Okay, that includes our tutorial for homework 17.